Today's lesson is about using sign diagram to predict the graph of rational functions. Let's talk about this topic according to the different rational function. If a rational function is a linear over linear pattern, we know that we have only one vertical asymptote line and one horizontal asymptote line. Now we focus on how many vertical asymptote line you have. Since we only have one vertical asymptote line, we have two intervals. Suppose this is x equal to a. For this interval that between negative infinity to a, this interval will be from a to positive infinity. Let's look at the right side of this vertical asymptote line. We have two parts, this part and this part. If your graph is above this horizontal asymptote line, you will sketch the graph like this, very close to these two vertical asymptote line but never touch. If your graph is below this horizontal asymptote line, the graph will be like this. For green one, the other one will be like this, very close but never touch. For black one, the other part will be like this. Therefore, if it's a linear over linear pattern, the graph, you have two choices, either like this one or like this one. For linear over quadratic pattern, we can write down ax squared plus bx plus c. Linear part, we can write down dx plus e. Normally, we have two asymptote lines. And a horizontal asymptote line will be y equals 0. So we draw over here. This two vertical asymptote line divide the number line into three parts. This is the one part. Another one like this. The other one like this one. Let's label 1, 2, 3. For interval 1, your graph either like this or like this. For interval 2, there are a lot of choices, sometimes like this, sometimes like this. It depends. For interval 3, definitely either like this or like this. Now let's discuss the third type of rational function, quadratic over linear. We can write down that is ax squared plus bx plus c. Then over dx plus e. Since numerator has one more degree than denominator, we have oblique asymptote line this time. Since denominator is only linear, therefore only one vertical asymptote line. Oblique asymptote line you can predict like this. Since we have only one vertical asymptote line, this vertical asymptote line divide the number line into two parts. For interval 1, either your graph like this part or your graph is over this part for interval 1. For interval 2, the graph will depend on the interval 1. This graph will definitely like this. And this part will be like this. Therefore, for quadratic over linear, you have two types of graphs. Now let's work on some examples. For the given rational function, this is a linear over linear. We will work on the roots and a 3 asymptote line to predict the graph. For roots, we have 3x minus 6 equal to 0. X equals 2, 0. Vertical asymptote line, that is 5 minus 2x, denominator equal to 0. So x equals 5 over 2. That's vertical asymptote line. Horizontal asymptote line, we will get the limit as x approaches infinity of leading coefficient. This is leading coefficient, this is leading coefficient. Therefore, we got 3x over negative 2x. Reduce first, then you will get negative 3 over 2. So y equals negative 3 over 2. No oblique asymptote line, because for oblique asymptote line, that is 1 more degree. Now we draw number line to predict this graph. You will label vertical asymptote line and roots on this number line. We got here's 2. This will be 5 over 2. For 5 over 2, we will draw this vertical asymptote line. Now choose a specific number. We choose 0. Then we plug 0 into this function. You will get 3 times 0 minus 6, and 5 minus 2 over 0. Then you will get, this is a negative 6, this is a 5. It will be negative, less than 0 is a negative. So we will label this is negative. And for 2, we got from here, single factor, change sign. 5 over 2 still single factor, this is a negative. Next step, we will sketch horizontal asymptote line or oblique asymptote line. We have horizontal asymptote line that's a negative, means below this number line. Let's draw like this. Then let's check each interval. For this number line, we have 3 intervals. Let's label as 1, 2, 3. For interval 1, let's check this vertical asymptote line. You will get this is this interval look like. Either your graph like this or this one. But check the sign. This has to be all negative. Therefore, this will be the graph look like. For second interval, positive, they have to pass through these zeros. So you will go positive like this. And then this part is negative like this. Positive means above the number line. Negative means below the number line. Now let's go to number 2. For domain that's x not equal to 3 and negative 2. Vertical asymptote line x equal to 3. And also x equal negative 2. For roots, you will make a numerator equal to 0. Therefore, your x equals 1 over 2. For horizontal asymptote line, let's get the leading term. We got the x squared, top is 2x. 2x over x squared. Reduce, you will get the 2 over x. Then you plug infinity to this x, you will get 0, y equals 0. No oblique asymptote line. So on the number line, we will label roots. Then vertical asymptote line. This will be the big dot because that's the root. I will test 0. So f of 0 equals, I plug in, you will get 2 times 0 minus 1, and 0 minus 3, 0 plus 2. You will get 1 over 6 greater than 0. You will label positive here. Since for factor it's all single factor, means change sign for neighbor interval like this. Then get the horizontal asymptote line will be x-axis. So let's draw something like this. So we have 1, 2, 3, and 4 intervals. For first interval, that's positive. Definitely the graph will be like this. For second graph, it's negative, means below this number line, but has to pass through these points. Therefore, we'll go down like this. For third interval, it's positive. That's why it has passed through these points. We'll graph like that. Check the vertical asymptote line, very close but never touch. For interval 4, negative, definitely is below this x-axis, which means number line. Now let's go to number 3. Factor. You will get the x minus 6, x plus 2, then x minus 5. Your roots, that will be set up x minus 6, x plus 2 equal to 0. So you get a 6, 0, and a negative 2, 0. Vertical asymptote line, denominator equal to 0, x minus 5 equal to 0, x equal to 5. This is a vertical asymptote line. For horizontal asymptote line, we need to check leading term, x squared and x. X squared over x, that's equal to x. Then we plug infinity into this x. You will get infinity. That means not available. For oblique asymptote line, let's use this one. So, root in the corner, x minus 5 equal to 0, x equal to 5. We put the 5 in the corner. No missing power, we got the 1, negative 4, negative 12. We only focus on the first two because we are only interested in the quotient. So we get the 1. Multiply is 5. We got the 1. That means x plus 1. That's the oblique asymptote line. So we write down oblique asymptote line y equals 1x plus 1. Now let's draw the number line. Get -2, 5, and 6. 5 will be the vertical asymptote line. Still, we need a 0. When we plug in 0 to this rational function, you will get the 0 minus 6, 0 plus 2, over 0 minus 5. You could see it's a positive. Therefore, I label this as a positive. Since for this rational function is all single factor, we change the sign. This is positive. For oblique asymptote line, always you need to figure out 2 points. First of all, it's oblique asymptote line passing through this x-axis. So you will set up x plus 1 equal to 0, x equal to -1. We got the -1, 0. Another point, it will be the oblique asymptote line pass through vertical asymptote line. Vertical asymptote line, that's x equals 5. So we plug 5 into this oblique asymptote line. You will get the 5 plus 1 equals 6. So we got the 5, 6. Always when you sketch oblique asymptote line, you have to get these 2 points. Therefore, you will get -1, 0 supposed to be here, and 5, 6. 6 is above this x-axis. Then I connect these 2 points. This will be your oblique asymptote line. For zeros, I will draw a big dot because your graph has to pass through that. Pass through this 6. Positive, that means like that. Above this number line. And negative means below this number line. See the graph like this. We already know the pattern. If we have the oblique asymptote line and a vertical asymptote line like this, one like this part, the other must be like this. So we could say from -2, the graph will be like this. Positive means above the number line, negative means below the number line. Now for number 4, vertical asymptote line, you will make a denominator equal 0. Therefore, we got x equals 3 and x equals -3. This is a vertical asymptote line. For roots, we will make a numerator equal 0. Therefore, we got -1, 0, and 1, 0. For horizontal asymptote line, we need to figure out the leading term. You have 3, this is x, from this one is x. Denominator x, x. Therefore, for leading term, you will get the 3x squared and x squared. Then we reduce, you will get 3. Therefore, y equals 3 will be the horizontal asymptote line. Oblique asymptote line not available. Now let's draw the number line this time. Label vertical asymptote line and the roots on the number line. We got -3, -1, 1, and 3. For 3 and a negative 3, this is a vertical asymptote line. Then we choose special number 0. Plug in. F0 equals 3 times 0 minus 1, 0 plus 1, 0 minus 3, and 0 plus 3. Positive, negative, positive, negative, positive. So you will get positive, positive. Since all of these are single factor, we change the sign like this. Let's make a big dot for zeros now. Let's sketch the horizontal asymptote line. Y equals 3 means above this number line. You will get this one. Let's go to interval 1, 2, 3, 4, 5. For interval 1 and 5, it's easy to sketch because positive, definitely you have to draw like this. For 5, positive, the graph will be like this. For interval 2, negative, that means this is the 0, negative definitely is going down. For interval 4, this is the points is going down like this. But between negative 1 and 1, the graph, is it passing through this horizontal asymptote line or not? You have to figure that out. Either the graph is this or the graph like this. You need to check which is the correct answer. We will set up this function 3x minus 1 x plus 1 over x minus 3 x plus 3 equal to 3. Then cross multiply. These two will be x squared minus 1. This two is x squared minus 9. Therefore, we do cross multiply. You will get 3x squared minus 3 equals 3x squared minus 27. 3x squared, 3x squared is gone. You get negative 3 equals negative 27. It won't happen like this forever. This means the graph won't pass through this horizontal asymptote line. Therefore, the graph will be like this. For number 5, first of all, factor. Your vertical asymptote line, you will set up denominator equal to 0. You get the x equals to 4 and x equals to negative 2. For roots, you will make a top equal 0. Since this is a cubic factoring, that means this one cannot be 0. In other words, only x minus 1 equal to 0, so x equals to 1. 1, 0 will be the root. No horizontal asymptote line. Oblique asymptote line, we have to do long division or synthetic division. Let's check long division. No missing term. X third plus 0x squared plus 0x minus 1. Then get the x squared minus 2x minus 8. We just need a first term. So you will get the x. Then x third power minus 2x squared minus 8x. Then change the sign adding. You will get the 2x squared. Then you can stop, because from 2x squared, you will get 2 plus 2. This will be the quotient. So y equals x plus 2 will be the oblique asymptote line. Now let's draw the number line. You got the -2, 1, and 4. For -2 and 4, it's a vertical asymptote line. For 1, that's 0. Choose 0 over here, plug in. You will get this one is -1, here's -8. When you plug 0 in. Therefore, positive here. It's all single factor. We need to change the sign like this. For the oblique asymptote line, we need 2 points. We already got -2. X equals -2. Then y equals -2 plus 2 equal to 0. That means over here. Then we use x equals to 4. Plug in. We got the 4 plus 2 equals 6. So it's supposed to be here. Then connect these 2 points. That will be the oblique asymptote line. Positive means above x-axis, means above this number line. Definitely the graph like this. Look at this domain between -infinity to -2. Negative definitely will go this way. Then check this 0. This interval is negative, means below this number line. Definitely go this way. Positive, that means go this way. That's how you predict your graph.